morning. This is Dr. K. Abdul Basith, working as a professor of CSC in Department of CSC, Marri Laxman Reddy Institute of Technology and Management. Today, we are going to discuss about the concept of functions. Before discussing about the functions, first of all, we need to know about what is subprogram. Subprogram is a part of the program which performs specific task. Part of the program which performs specific task. Subprogram is divided into functions and procedures. Coming to the functions, functions are subprograms which performs a task but which returns a value. Procedure is also a subprogram which performs a specific task which does not return any value. Here, some of the languages, subprogram concepts are implemented in the form of functions. In some of the languages, subprogram concepts are implemented in the form of procedures. Some of the languages supports both procedures and functions. Here, we are interested in functions. So, a function is a subprogram which performs a specific task and it returns a value. A function must return a single value. The function which is not returning any value, it is called as a void function. Void means nothing. So, before going to functions, a function comes under derived data types. C supports 4 types of data types. One is predefined data types or primary types. Second one is derived data types. Third one is user defined data types. Fourth one is empty set. So we already know about primary data types. Int, float, char, double, long, double, they are comes under primary data types. And coming to the derived data types are derived from primary types plus some kind of typo operators, we are deriving new types. So for example, primary data types plus typo operator asterisk, we are deriving a new type called pointers. Primary data types plus typo operator subscripts, we are deriving a new type called arrays. Primary data types plus typo operator parenthesis, we are deriving a new type called functions. So function is a derived data type and they are deriving from primary data types plus the typo operator for function we are using is parenthesis. So functions in C, they follow top-down design to implemented by using functions in C. So a program in C made up of one or more functions. One and only one function you are naming as main. Every C program have single main. The execution of the program always starts with the main function. The operating system give the control to the main function. So every C program starts execution with main, but it can call other functions based on the requirement. So main is called by the operating system and control returned to the operating system after completion of main program. So advantages of function. So using function, we can easily code and debug. We can easily write the program and we can easily handle the program by debugging is correcting the errors which are occurring during the program. So functions can be developed by different people and can be combined together as one application. This is called modularization. So modularization can achieve using the concept of functions. And function supports reusability. Once you write the code, you can call many number of times. So you can use the reusing of the code is occur because of functions. So function supports reusability. And solving a problem using different functions make programming much simpler and with fewer defects we can solve the problems. So the functions can reduce repetition of the same statements in the program, and the functions makes code readable, providing modularity to your program. There is no fixed number of calling functions. You can use n number of functions. You can call n number of times. The function reduces the size of the program. Once a function is declared, you can just use it without thinking about the internal working of the function. These all are comes under advantages of functions. If you go for disadvantage of functions, it cannot return multiple values. A function can return a single value at a time. And memory and time overhead due to stack frame allocation, transfer of program control. So the memory, it takes more time for storing, and the functions uses local variables, and the local variables uses the data structure called stack. The stack should take a time for performing push and pop operations. So because of this, it is very slow. So you can see this, a workman allotment means a work is allotted to a group of people, and the individuals are worked together, and their solutions are given, and combine the solutions into one application. Then the application was released here. So here, this is the example for modularization. The project is divided into number of modules, each and every module identified by a person. A person can solve the problem or implementing the code for the module, and finally they collect the module and release the application. So this is the example for modularization. So if you consider a function is divided into two types. One is predefined function, another one is user defined function. So predefined function, how the predefined functions or user defined functions are different from each other. So whenever you talk about a concept of function, you need to remember three characteristics of the function. A function must declare, a function declaration is required, function definition is required, function calling is required. These are the three characteristics of the function. If you consider predefined function, or if you consider user defined function, you need to follow these three characteristics. So how the predefined functions are different from user defined function? Predefined functions, the declarations are available in header files, in the header files, like example stdio.h you can take. It is a header file which consists the declarations of printf and scanf, predefined functions. So function definition, so for the predefined function definition is available in C library in the form of object code, and the function calling, user only call the predefined functions. So user calls the predefined function, the declarations available in header files and the definitions available in C library. During the compilation process, they are linked together. And these predefined functions are also known as library functions. So coming to the user-defined function, the function declaration, function definition, function calling, all these three user is responsible. Because of that, it is called as a user-defined function. We are interested in user-defined functions. So if you consider user-defined function, how you declare the user-defined function? So user-defined function having a syntax to declare. The syntax is return type followed by function name, then parameter list. Here it is also called as a header. It is also called as function declaration consisting a header. And function declaration you can also call prototype of the function. So you are telling the compiler that what return type is the function is having, and what is the name of the function, and what are the parameters of the function, what type of parameters you are going to pass. All this information is given to the compiler. So for example, if you consider any variable declaration, so you are telling the compiler so and so name of the variable, so and so purpose we are using, so the type we are telling, the address we are giving, so all these things. So giving information to the compiler, like variable, whenever you are using a function also, you must declare the function first, and you need to tell what kind of value you are going to return, what kind of parameters you are going to pass. all this information required for the compiler. So the declaration gives or prototype gives this information to the compiler. So here, so the return type, for example, if you write int, the return type means the function is returning integer. And the heading, this is name, function name is nothing but valid identifier. And here parameter list, if you are not passing any parameters, then you are writing this void means nothing. So now this is example you can take. In this example, the return type is float, and the name of the function is called find area, and we are passing two parameters for this. These parameters here called as a formal parameters. These parameters are called formal parameters, and here each parameter is identified by some type, data type, parameter type, and here each parameter is separated by comma, and this declaration must end with semicolon. So here note, a function in C must always declare globally before calling it. If you declare the function, we can declare either local or global, but what happens if you declare the function globally, so you can call that function anywhere in the program. So coming to the second characteristics, that is called function definition. In a function definition, we are writing two things. One is header, another one is body. So the header, which consisting same declaration type, so return type, function name, and list of parameters. Only the thing is, in declaration the header end with semicolon, but the function definition, the header should not end with semicolon. Here we are not writing any semicolon. And here, see this example you can take, int heading void. So here the header is not ending with semicolon, no semicolon is used here, and the int is given as a return type. Heading is the name of the function, and these are called formal parameters. And the body, which is enclosed in open brace and closed brace, here we are writing some executable statements. And this body consisting two parts, local part and execution part. In local part, you are declaring local variables. In execution part, you can write executable statements. So this is all about example for function definition. And if you go for third characteristic is called function call. So a function call is a statement that instructs the compiler to execute the function. We use the function name and parameters in the function call. So the function call is a postfix expression. It is called as a postfix expression. And the operands in a function call, in the function name, the operator is parenthesis, and the which contains the actual parameters. Here the parameters are two types. One is called actual parameter, and another one is called formal parameter. The actual parameters are whenever you are calling the function, you are passing some parameters. Those parameters are called as actual parameters. While you are defining the function, you are writing some parameters. Those parameters are called as formal parameters. Here again, we need to remember three properties here, or three characteristics we need to follow. One is the number of actual arguments are equivalent to number of formal parameters, and the type of actual arguments are equivalent to type of formal arguments, and the order of actual parameters should be equal to the order of formal parameters. These three things you need to remember. If any mismatches occur, so it will generate an error. And multiple actual parameters separated by comma. Function call transfer the function definition to the function definition. Call, if whenever you call the function, control transfer to the function definition. After execution of the function, control returns to the calling function. Function having a return type void can be used as one standalone statement. So you can see this general form of function call. So return type, function name. Here return type is equal to, you are writing return type variable, you can take here, is equal to, you can write a function name passed by some parameters, parameter 1, parameter 2. So here you can see a multiply 6 comma 7 is nothing but a function call, means the multiply is not returning anything, so no return value. That is a void function, but it is passing a parameters, and these parameters are constants here, and these parameters are one constant, one variable. A function call can call another function, same function or another function as a parameter. It is also function call allowed. And here you can write a function passed as a two expressions as parameters. The result of the expression you can pass it as a parameter. So these are the general form for function calling. How the function is work? So whenever a function call occur, control jump to the definition of the function. It performs the task. After performing the task, control goes back. So this is the function work. Like this function will work. So working functions in C, for example, you can consider a function called sum. The name of the function is sum here, and the return type of the function is integer. And here we are using two parameters here called formal parameters. So int a and int b, these are the two parameters. So this totally is called as a function header. And the function body consisting a return statement, return a plus b. So return is a statement which returns a value to the calling function. So even though you define the function, but you are not calling inside the main, they will not execute it. So every C program starts execution with the main and end with the main. So here the first one you are calling int add is equal to sum of 10 comma 30. So you are calling a function, control goes here. Here 10 comma 30 are called actual parameters, and these actual parameters are copied to formal parameters. 10 is copied to A and 30 is copied to B, and here 10 plus 30 is performed, that is addition is performed. So totally 40. 40 it will return. 40 is an integer type, that's why the int is a return type we are using, and this the value is assigned to a variable called int add. So the 40 is assigned to add, and printf add means it prints 40. So note here function call is necessary to bring the program control to the function definition. If not called, the function statements will not be executed, because C program starts execution with the main, end with the main. Inside this you need to call the function, even though you wrote or you define somewhere else, but you must call inside the function. If the function main function calls function A, in function A you call function B. So if you are not calling function A inside function main function, A will not be executed and B also not executed. So example you can consider. So here in this example, what I am doing, I am using a function called multiply, and the return type I am using is integer, and this multiply function having two parameters, two formal parameters. One is called multiplier and another one is called as multiplicand, and these each parameter is each parameter mentioned with this type. And here the declaration, this is called function declaration. The function declaration must end with a semicolon. And here you are using a main function. In the main function you have two things here, local part and execution part. Local part and variable declaration part and execution part you are declaring. In a variable declaration part you are declaring a product. In a execution part you are writing a product is equal to multiply 6 comma 7. So 6 comma 7 they are called as actual parameters, and whenever function call occur, control goes to the definition of the function. In the definition function we are using multiply int x int y. These int x int y are called formal parameters, and here the actual parameters memory is different, formal parameters memory is different, and 6 is copied to x and 7 is copied to y. And here 6 into x into y is performed, the return value is returned to the 42 is returned to the multiply, and it is assigned to the product. It receives the return value and it comes out of the main function. So this is how the functions are used. So another program you can consider, C program to show function call and definition. See this, in this program what I am doing, I am taking a function definition here. So function definition you are defined globally. There is no need to declare. If you are defining the function somewhere else, not in a global, so you can declare first. Once you define the function, there is no need of declaration. So here in this I am not declaring, I am directly defining function definition. In this function definition I am before main I am telling, that's why it is called as a global function. And here I am performing a plus b, and for this I am passing the data from here addition. is equal to sum of 10 comma 3. So this is called function call. Whenever call occur, control goes to the definition of the function. It pass the parameters to, so 10 is copied to A and 30 is copied to B, and it performs 10 plus 30, that is 40. 40 is written to add. So based on the parameter passing and the return values, we are having 4 types of parameter passing methods. The first one is void function without parameter, void function with parameters, non-void function without parameters, non-void function with parameters. Based on the parameters and the return values, functions are classified into 4 types. Now first one, void function without parameters. In this, without parameters means you are not using any actual arguments. There is no actual arguments. Here we are not passing any arguments, and it can used only as a statement because void function does not return value. So it is not returning any value, the return type must be void. The return type must be void. If you are right, you are not returning the value, the calling is a standalone statement. It cannot be used like this. So it is not a standalone. If you use like this, it is an error because it is a void function. Void means nothing, means your return type is void as well as the parameters also nothing, void. So this is the category 1, class 1, void function without parameters. And coming to the second case, a void function with parameters, the function that receives parameter but does not return any value. This function takes arguments, means we are having actual parameters and we are having actual parameters and followed by formal parameters, but there is no return value. So for example, you can see this in this function, while you are calling, you are passing a parameter. A is called as a actual parameter and X is called as a formal parameter. So assume A is having address 1000 and X is having address 2000. So when a call is occur, this value is copied to this 1000 to 2000 in place of 2000. So now you are performing this task. So means a function, you are passing some parameters, then it is called as a function passing with parameters and there is no return value, then it is called as a void function with parameters. If you write like this, here you are mentioning that result is assigned to the return value, means it is a error here. Third case, non-void functions without parameters. The function returns a value but does not receive parameters, means there is no actual parameters. If actual parameters are not there, there is no concept of formal parameters, but we are having some return value. So that is example for this. See this, in this get quantity is the name of the function which is having a return value but no parameters it is having. So while you are calling, you are not passing any parameters, but based on the return value, so when the call occur, control go to the definition and it executes. After executing this, you are returning this quantity and this quantity is assigned to amount. So like this, the third case. And coming to the fourth case, non-void function with parameters. So the function receives parameters and return values, means here we are having actual parameters and we are also having formal parameters and we are also having a return value. All are there. So this is the fourth case. See, here the function is sqr. In this, the name, the return value is integer and the parameter you are going to pass is x. So while you are calling the function, you are calling by the parameters. So in the definition, you are receiving the parameters. Here a is the actual parameter and x is a formal parameter. Actual value is copied to formal parameter and you are performing the task. After performing the task, you are returning the value and the return value is assigned for b. So that is all about 4 types of parameter passing methods. Now, the data passed when the function is being invoked is known as actual parameter. While you are calling the parameters, while you are calling the function, there are 2 types of parameters. One is called actual parameter, another one is called formal parameter. In the function calling, you are calling the function by passing some parameters. It is called as actual parameters. In the definition, you are writing some parameters. Those parameters are receiving the data from calling function. These parameters are called formal parameters. Here we need to remember 3 things. The number of actual parameters should be same. Here 2 numbers we are using. Here 2 numbers. Number of actual parameters is 2. Number of formal parameters is 2. Here you are passing type of actual parameter int. Here also type int. Order also should be same. So if you pass int float in a actual side, in a formal side also you should write int float only, not float int. So if any mismatch is occur, it will generate error. In this program, see 10, 30. These are called actual parameters, and A, B. These are called formal parameters. So interfunction communication. Most programming languages have 3 strategies for interfunction communication. One is pass by value, another one is pass by reference, and a third one is pass by reference, pass by name. Third one is pass by name. So here C supports 2 types of one. One is call by value, call by reference. Here call by value is also known as pass by value. Call by reference is also known as pass by value and return. So coming to the call by value mechanism. In a call by value mechanism, parameter passing this method copies values from actual parameter to formal parameters. As a result, any changes occur inside the formal parameters which will not reflect actual parameters. For example, you can consider here, I am using a function called swap. And here, every C program starts execution with main. In that main, what I am doing, I am declaring variable 1, variable 2. And before swapping, I am calling the function variable 1 comma variable 2. So whenever call occur, control comes here. See this variable 1, assume variable 1 having address 1000, variable 2 having address 2000. So variable 1 consists of value 3 and variable 2 consists of value 2. Whenever call occur, control goes to the definition of the function and the main function is suspended and swap function will be active. In that time, here in a function side, variable 1 is a formal parameter having address 3000, assume. Variable 2 another variable that is also having address 4000. Since this memory location is different, these memory locations are different. So now what happens when a call occur, this 1 is copied to here, that is 3 come here, and this copied to this second argument and 2 comes here. Here what I am doing, I am performing swapping using a temporary variable. So after swapping, it becomes 2, it becomes 3. But they are modified here. They're not reflecting here because these values are not modified. Why? Because in call by value, actual parameters having different memory, formal parameters having different memory. If you modify formal parameters, will not reflect actual parameters. So this is the mechanism of call by value mechanism. Coming to the second mechanism, that is called call by reference. In call by reference mechanism, instead of passing a value, you are passing address. So if you pass the address as a parameter, the receiver must be pointer, the formal parameter. If the actual parameter is address, the formal parameter must be pointer because pointer only stores the address of the variable. Pointer only stores the address of the variable. So here what happens, for example, assume variable 1 is a variable, variable 2 is another variable. Assume this address is 1000 and this address is 2000. So what happens here, when a call occur, control goes here. Here you are using 2 pointers. One is a variable 1 is a name of the pointer. Variable 2 is another name of the pointer. This address is 3000. This address is 4000. What you are doing, you are passing address of variable 1, address of variable 2. Address of variable 1 is 1000. Address of variable 2 is 2000. You are indirectly, it is pointing to this. It is pointing to this. So if you modify anything here, so assume this is 3 and this is 2, this is 2. So what you are doing, using the indirection operator, temp is equal to value at address variable 1. So temp is equal to value of variable 1. Variable 1 pointer consisting 1000. So value of 1000 is indirectly, it is 3. So it is 3. So now temp consisting 3 now. So next statement, value of variable 1 is value of variable 2. So means this 2 is copied here, and next variable 2 is equal to temp, that is 3 comes here. Means if you modify formal parameters, because of this they also reflect at the actual parameter side. So this is the difference between call by value and call by reference. So in call by value, so formal parameters are different, actual parameters are different. If you modify formal parameters, they will reflect at they will not reflect at the actual parameters. But in case of call by reference, so indirectly you are accessing the same memory variables. Because of that, if you modify formal parameters, which also affects actual parameters. That is the difference between call by value and call by reference. So this is all about, these are the references I used. So concept of programming languages by Robert W. Sebesta and computing fundamentals in C programming, second edition by E. Balaguruswamy, and we also uses a website greeks.org. Hope you understand the concept of functions. Thank you.